In this episode, we focus on a challenge that shows up in almost every organization that builds software: how to make secure coding expectations real in day-to-day work without turning delivery into a slow crawl. Beginners often imagine secure coding as a list of rules you memorize, but in practice, secure coding is a behavior pattern that has to fit into real schedules, real teams, and real constraints. If expectations are too vague, people interpret them differently and security becomes inconsistent. If expectations are too strict or too heavy, people work around them, and security becomes a paperwork exercise that nobody trusts. The goal is to operationalize secure coding, meaning you make it part of how work naturally happens, with clear definitions, simple feedback loops, and predictable ways to handle exceptions. This is less about heroic developers writing perfect code and more about creating an environment where secure decisions are the default and risky decisions are visible early. When done well, secure coding can actually speed delivery over time because fewer defects escape to later stages where fixes are expensive. By the end, you should understand what it means to operationalize expectations, what makes secure coding programs fail, and how to balance security and delivery in a way that produces steady improvement instead of constant conflict. A good place to start is to define what secure coding expectations are at a practical level, because they are not the same as general security goals. Expectations are specific behaviors and standards that developers are expected to follow when writing and reviewing code, and they should be stated in a way that can be checked. For example, an expectation might be that input is validated before it is used, that access checks are enforced consistently, or that sensitive data is handled carefully throughout its lifecycle. Even without diving into implementation details, you can see that these expectations describe patterns that apply across many features rather than one-off tricks. Beginners often get stuck on individual vulnerabilities, but operationalizing secure coding is about preventing classes of vulnerabilities by making good patterns routine. Expectations also need to be scoped, because not every part of a system has the same risk, so you may have a baseline set that applies everywhere and additional expectations for areas that handle sensitive assets. Another key point is that expectations should be written in plain language that developers can act on, not in abstract policy language that sounds impressive but leaves people guessing. When expectations are clear and shared, they become the foundation for consistent reviews and consistent decisions. One reason secure coding efforts slow delivery is that they are introduced as extra work rather than as integrated work, which makes them feel like a tax added at the end. If developers learn about a security expectation only after a feature is built, then meeting it requires rework, and rework is what creates schedule pain. Operationalizing expectations means moving them earlier, so developers know what good looks like when they are making design and implementation choices. It also means building lightweight ways to check expectations continuously, so problems are caught while they are still small. Beginners should realize that a small change early is easier than a large change late, and secure coding is largely about making risky patterns visible early so they do not spread. Another reason delivery slows is uncertainty, because when people are not sure what security wants, they stop and ask questions, or they guess, and then get corrected later. Clear expectations reduce uncertainty, and reduced uncertainty increases speed. The best secure coding programs feel like guardrails that keep teams on the road rather than like roadblocks that stop progress. This mindset is essential if you want security to be accepted as part of quality rather than rejected as friction. A practical approach to operationalizing expectations is to focus on a small set of high-impact secure coding themes that cover most real risk. Themes like authentication, authorization, input handling, data protection, error handling, and logging tend to be the places where major security failures happen. You do not need to teach every detail at once, because beginners and even experienced developers learn better when expectations are grouped into understandable patterns. For example, authorization expectations can be expressed as the system must enforce access checks server-side for every sensitive action, and that expectation can then be applied across many features. Input handling expectations can be expressed as never trusting external input and validating it against expected formats before using it. Data protection expectations can be expressed as treating sensitive data as sensitive by default and limiting where it can appear, such as logs and error messages. When expectations are grouped into themes, teams can build shared vocabulary and recognize patterns quickly. This reduces the cognitive load on developers, which helps delivery speed because people spend less time decoding security advice. It also helps reviewers because they can look for a handful of patterns rather than trying to remember an endless list of issues. Code review is one of the most important places to operationalize secure coding expectations because it is where teams already have a habit of checking each other's work. The key is to make security checks a natural part of review rather than an extra process that happens only sometimes. That starts with making expectations visible to reviewers, such as through lightweight review prompts or checklists that remind people to look for specific patterns, without turning review into a bureaucratic ordeal. Beginners should understand that code review quality depends on clarity, because vague comments like "make this secure" are not helpful, while specific questions like "where is the access check" enforced lead to better outcomes. Another important point is that secure coding review should focus on the high-risk areas first, such as new data flows, new permissions, or new ways to accept external input. If every review treats every line of code as equally risky, reviews become slow and superficial. When reviews are risk-focused, they are faster and more meaningful because attention goes to where problems are likely. Good review culture also avoids blame, because blame makes people hide issues, and hidden issues become incidents. Operationalizing expectations in review means making security feedback routine, consistent, and teachable. Another way to avoid slowing delivery is to clarify what is mandatory versus what is recommended, because not every security improvement needs to block a release. Beginners often assume security must be absolute, but in reality, organizations prioritize based on risk and timing, and that is not irresponsible when done transparently. A mandatory expectation might be something that prevents obvious high-impact problems, like enforcing access checks or avoiding unsafe data exposure. A recommended improvement might be something that makes the system stronger but can be scheduled if the risk is lower, such as refactoring for cleaner boundaries. The danger is letting everything become optional, which makes expectations meaningless, but the opposite danger is letting everything be a blocker, which makes teams resent security and search for shortcuts. A balanced approach includes clear criteria for what must be fixed before release and what can be tracked for later, with an explicit way to record the decision. This keeps delivery moving while still making risk visible and managed. It also prevents last-minute arguments, because the rules are known ahead of time. When teams know the thresholds, they can plan work and avoid surprise delays. Training and enablement are part of operationalization because expectations are only useful if people understand how to meet them. For beginners, it is important to realize that secure coding is learned through examples, patterns, and feedback, not through memorizing abstract definitions. Developers need to see what good looks like in their own code base, using the frameworks and styles they already use, because generic advice can be hard to translate into action. Enablement can include reference implementations, reusable components, and shared guidance that shows how to handle common needs securely, such as access enforcement or safe input handling. The key to not slowing delivery is to make the secure path the easy path, so developers do not have to reinvent solutions repeatedly. When teams have ready-to-use patterns, they can move faster while also being safer, which is the ideal combination. Feedback loops also matter, because if developers only learn about problems weeks later, learning is slow and frustration is high. Immediate or near-immediate feedback helps people improve quickly and reduces rework. Operationalization treats secure coding as a skill built over time rather than as a one-time policy announcement. Another major factor in delivery speed is how the organization handles exceptions, because real-world projects always face deadlines, legacy code, and constraints. If security expectations are enforced rigidly without an exception process, teams will either miss deadlines or work around controls quietly. If exceptions are granted casually without documentation, risk becomes invisible and accumulates. A good exception approach makes trade-offs explicit and temporary, meaning you can say we are accepting this risk for now, here is why, and here is when we will revisit. This keeps delivery moving while also maintaining accountability, because leaders know what is being deferred and can plan remediation. Beginners should see that exception handling is not about being lax, It is about being honest about constraints and managing them responsibly. It also helps security teams focus on the most important issues because they can reserve strict blocking for the highest risk problems. Over time, patterns and exceptions can reveal systemic issues, such as missing secure components or unclear expectations, which can then be fixed to reduce future exceptions. This is how operationalization improves, by learning from where reality collides with policy. A mature process turns exceptions into improvement signals rather than into permanent loopholes. Measurement also matters, because if you cannot tell whether secure coding expectations are improving outcomes, you cannot tune the process to balance security and speed. The wrong measurement is counting how many issues are found, because that can encourage noisy reporting and fear rather than real improvement. Better measurement looks at outcomes like fewer repeat issues, faster resolution of common problems, and fewer late-stage security surprises. It can also look at how quickly teams can implement security expectations without rework, which indicates that secure patterns are becoming normal. Beginners should recognize that the goal is not to find endless flaws. It is to build systems where flaws are less likely and are caught earlier when they do happen. Measurement also helps you spot bottlenecks, such as security reviews that take too long or unclear standards that cause repeated back and forth. When bottlenecks are identified, you can adjust by improving guidance, clarifying expectations, or creating reusable secure components. The key is to use measurement as feedback, not as punishment, because punishment causes people to hide problems and to avoid asking for help. A healthy operationalization approach treats security metrics as a way to learn and improve, just like any other quality metric in software delivery. It is also useful to understand that operationalizing secure coding is easier when you focus on system design choices that reduce the need for perfect code everywhere. For example, if access control is centralized and consistent, individual developers are less likely to forget checks in individual features. If sensitive data is handled through a small number of well-designed pathways, developers are less likely to accidentally expose it in logs or error messages. This is not implementation detail, it is a design mindset. Create structures that make the secure behavior the natural behavior. Threat modeling and design reviews often point to these opportunities because they reveal where repeated risks occur. Beginners should notice that this is one of the best ways to avoid slowing delivery, because instead of asking every developer to remember every rule every time, you build a system that guides them. When the secure path is built into the architecture and shared components, security becomes less about constant policing and more about using the right building blocks. That also improves consistency, which improves trust in the security program. Over time, teams deliver faster because they are not constantly correcting the same types of mistakes. When you step back, operationalizing secure coding expectations without slowing delivery excessively is about making security a predictable, integrated part of how work happens. Clear expectations define the secure patterns that matter most, and those expectations must be written so developers can act on them without confusion. Integrated review practices make security checks routine and risk-focused, so attention goes to high-impact areas without turning every change into a major ordeal. A balanced approach to mandatory versus recommended items keeps delivery moving while still protecting critical assets and making risk visible. Training, reusable patterns, and fast feedback make the secure path easier than the insecure path, which is the most effective way to change behavior at scale. A clear exception process prevents silent workarounds and turns constraints into learning signals that improve the program over time. Finally, measurement and design-minded thinking help the organization continuously tune the balance between security and speed so secure coding becomes part of normal quality rather than a last-minute scramble. For a beginner, the most important takeaway is that secure coding is not a heroic act performed under pressure. It is a set of habits and structures that make safe choices routine, and routine is what allows both security and delivery to succeed together.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.